I'm going to start today by having you guys right away pause the video and see if you can do problem number 7 just as a review or refresher from yesterday. And then in a little bit after everybody's done, replay the video and check your work as you go. So I will meet back with you shortly. All right, I hope that went okay. I ended up getting 600 phones per day. Don't forget that you do have to subtract the fact that it is going to cost $80 per phone, and the cost is as well per phone, and you have to subtract the $7,000 cost of running your plant a day. And when you work through, it should be 600 as your final phones. 600 comes out to be the place where the function changes directions. It goes from increasing to decreasing. All right, so up next we are going to be exploring some other types of problems. This one is a supermarket employee wants to construct an open top box from a 14 by 32 piece of paper. To do this, the employee plans to cut out squares of equal size from the 4 corners so that the 4 sides can be bent upwards. What size should the squares be in order to create a box with the largest possible volume? This picture is a little bit tricky, so I'm going to do my best to explain kind of what's going on. I always think of it as like, here I have this flat piece of cardboard, okay? Flat piece of cardboard, and then I am going to put my measurements on this piece. It's 14 by 32. So what's happening is the employee is going to cut out little corners. And picture these little dotted lines that I get are squares, and they get cut out of each corner. That leaves me with these little tabs that are sort of sticking out. So what I'm left with is a piece that kind of looks like this. And you don't have to draw this every time, but this is sort of what I'm looking at. And then what the employee is going to do is take those tabs and fold them upwards, and he's going to create a box that doesn't have a top. And I always think of it as like maybe something that looks like a cake box. So here's my best rendition of that box. I'm going to try to do it with some perspective. Now keep in mind, your pictures are not what I'm going to be grading you on, so you don't have to be great at drawing this. But what I usually do is I start with a parallelogram, and then I give that parallelogram some height because it's with perspective. The height is the same, but it's going to be back further, so it's going to be kind of up higher, and then I'll connect the bottom. Now this is an open top box, so I can see inside. So there's sort of the creases that go inside. So there's my open top box. Again, you don't have to make, so this part is sort of inside of the box here. You don't have to make the picture, it doesn't have to be beautiful, but I do want to use the information that I had to create the dimensions for this box. So I cut out the corners. Those corners were X. That means this is an X length, and an X length, and X length, and X length. That means the height of this box is X, if you can picture you folding that up. So that's the height. Now what happens here is on this side, when I cut out these 2 X's, I'm cutting out 2 X's, one from each corner. This becomes 14 minus 2X, and I don't know what size X is. That's what I'm trying to figure out. And then same with on the bottom, when I'm cutting that out, I'm cutting out 2 X's, so that length is 32 minus 2X. And now what I want to do is I want to find the largest volume. Well, volume is length times width times height. Not necessarily in that order, so I'm going to start with the smallest. I'll go X times 14 minus 2X times 32 minus 2X. And then what I like to do is multiply this all together first to get a polynomial. So what I'm going to do is pause the video, have you guys multiply this all together, and then we'll come back and compare. All right, so I'm back, and what I did was I distributed the 14 minus 2X times the 32 minus 2X, and then I brought the X through again. I ended up with 4x cubed minus 92x squared plus 448x. And when I distributed it all, once I was done and cleaned it all up, I put it in descending order, and now I'm set to take a derivative. So v prime is 12x squared minus 184x plus 448. This is what I'm going to set equal to 0. And I am going to solve for that. Now, normally we would factor, but these numbers are pretty big. I'm just rewriting it up here because I ran out of room down there. But the numbers are pretty big, and so I'm going to have actually quite a few values that I'm going to be messing around with to see if it factors. That is, if it even does factor, because I don't know that yet. So to save myself some time, I'm going to rely on Old Faithful, and that is the quadratic formula, because it's sort of a no-brainer. I just pick out the A, the B, the C, and then plug it in my calculator. So my A is 12, my B is negative 184, and my C is 448. So I'm going to plug it into the quadratic formula. It is the opposite of B, oops, so that makes that positive, plus or minus the square root of B squared. Make sure when you're plugging this in your calculator that you put parentheses around the negative, otherwise it won't square the negative part of it. Then this is minus 4 times A times C. Ooh, real scrunchy here, sorry. That's 4 times 12 times 4, 88. This all goes over 2 times A. And then what I'm going to do is, again, plug this in my calculator, and you can do this however you want. Remember, we all math differently. We all came from different backgrounds, different teachers. What I usually do is plug this piece into my calculator, and I get a value for that. So when I plug that in my calculator, I end up getting 111.14-ish. So this is 184 plus or minus 111.14. And that's going to be divided by 24. So I'm going to have my two equations, 184 plus 111.14 divided by 24, and 184 minus 111.14 divided by 24. Again, when you plug these in your calculator, be careful. Please make sure that you are hitting equals before you divide. Otherwise, it will divide only 111 by 0.14, and then it'll add 184 to it, so we'll get numbers that are way off. When I do this, I get roughly 12.3, and then for the next one, when I plug it in, I get roughly 3.04. Well, which answer do I use? And this is, again, where making that min-max table is very helpful. I'm going to plug these both in on here, 3.04, 12.3, and I'm going to do my test points in here. So I'll try 1. That's 12 minus 184 plus 448. That comes out positive. So it's increasing. Then I'll plug in something like 4, and I might need to use my calculator to do that. 12 times 4 squared minus 184 times 4. Plus 448. When I plug that in, I actually get a negative region, which makes this decreasing. And then I'll go ahead and do the next section. Maybe I'll put in something like 20. 12 times 20 squared minus 184 times 20 plus 448. That comes out to be a positive region. And these numbers have to go into my derivative. And again, you might have to use your calculator for that. So I end up with a max at 3.04 and a min at 12.3. So 3.04 is the one that I'm interested in. So how do I answer this? What size should the squares be in order to create the largest box? And they should be 3.04 by 3.04 inches. I'm going to use the abbreviation with that double little sort of quote mark for inches. You could put IN in there as well. It doesn't really matter. But that's what I need, my square to be 3.04 by 3.04. And that's pretty much it for that one. Another problem where we only have one variable, we don't have to do a connector. Problem number 9, very much the same. So this is another situation where I want you to set it up, follow the method that was done in problem number 8. See if you can come up with the correct answer. Pause the video right now. Pause it for, I don't know, maybe give yourself 5 minutes to work through that, and then we'll get back together and compare the answers. I hope you all had a chance to work through that thoroughly. I hope you didn't get too confused, but when you did your distributing here, remember I like to distribute the 2 parentheses first, and then I'll bring the x through, and then I also put it in descending order. So when all was said and done, I got 4x cubed minus 52x squared plus 160x. Then I went ahead and did my derivative. And I wasn't going to waste my time trying to factor it. Turned out that this one was factorable. The first one wasn't, but this one was. But I didn't waste my time anyways. I went through and set up the quadratic formula. I actually got it to be exact value. That's what made me know it was factorable. It came out to be exactly 56. And when I plugged that in, I got 6 2/3 and 2. And so I made my f prime table and found 2 to be the exact, or to be the max. And therefore I did a 2" by 2" square. What size should the squares be in order to create the largest possible? That gave me my max. So that's our first type of problem for today. We have 2 other types that we're going to do. And so our next one is with a graphic designer creating a movie poster. Moving right along. I'm going to do one. I'm going to have you do one. And then we'll do our last problem. So in this one I have a graphic designer creating a movie poster that has a 50" squared photo surrounded by a 2" border on the top and bottom and a 1" border on each side. What overall dimensions for the whole poster should the designer choose to use the least amount of paper? So least amount of paper tells me minimum product that I want to use, smallest amount. So I'm going to start with the photo. This is a 50" squared photo. So I know this is 50 inches squared on the inside. That's what it's going to be. I don't know what X and Y are. That could be 5 by 10, could be 2 by 25. I don't know what they are. I just know that this has to be 50 inches squared on the inside. So I'm going to call this X and Y. This is another one where I've got 2 variables that I'm dealing with. Then I'm going to go ahead and put my border on. And it says that the border is 2 inches at the top and at the bottom. So there's 2" border height here at the top and another 2" border height at the bottom, making this whole side be 2 plus y plus 2, or y plus 4. So that's the new height. 2 inches on the top, the full length of y, 2 inches on the bottom, y plus 4. Now along the side, they have 1 inch on the left and on the right. So 1 and 1. So when I go across there, it is 1 plus x plus the last one. So 1 plus x plus 1 is x plus 2. I want the least amount of paper, so I'm looking for the least amount of area used. Least amount of paper, this is area problem. I am going to go ahead and multiply x plus 2 times y plus 4. That's going to be my area. 2 variables. We haven't done a derivative on 2 variables yet. You'll learn that in calculus. Right now we haven't done that. So what do I use as my connector? Well, the one thing I know is that the product of x and y has to be 50. So I go ahead and make that connector, and I'm going to do that in a different color. I know that x, y has to be 50. That product has to be 50 because I know that that picture is a 50" squared photo. I'll solve for either x or y. It doesn't matter which one. I'm going to go with solving for y. That is 50 divided by x. And then that's what goes in for y. So I have a new equation that is area equals x plus 2 times 50 over x plus 4. Distribute that all through. My area is 50, x times 50 over x, the x's will cancel out, plus 4x plus 100 over x plus 8. So my area is, I'm going to do a couple things here. Combine like terms, and because I know I'm going to have to do a derivative, I'm going to change this value to a negative power, so it's easier for me to do my derivative on it. So this is 58 plus 4x plus 100 times x to the negative first. So it's a lot easier for me to take a derivative with a negative power than it is for me to do a quotient. That's why I change it to that negative power. And now when I do my derivative, I have 4 minus 100x to the negative second. Now, like I said, this is a prime, sorry. When I do my derivative, I get 4 minus 100x to the negative second, multiplying 1, lower the power 1. It is easier for me to do my derivative with a negative power, but when I'm solving for x, it is much easier for me to work with a positive power. So when I set this equal to 0, I'm going to bring that 100 back down to the bottom. Excuse me. Now I need to solve. So I'm going to add the 100 over x squared over, and then multiply the x squared out of the denominator. Divide the 4 out, and take the square root. Technically, my answers are plus or minus, but minus doesn't make any sense because I'm talking about a dimension. So I'm not going to worry about the negative value. It's just a non-issue in this problem. It doesn't make sense to it. So the one I'm going to work with is 5. So I know I have a dimension of 5 for x. And so I am going to go ahead and check to make sure that this is in fact a minimum that I want it to be. And I'll go back up right in this place. This position right here will be good for me to do my checkpoint. I'm going to try 1. 0 doesn't make any sense, and I can't divide by 0 anyways. So this is 400 minus 100 divided by 1 squared. That's a negative, so decreasing. Then I'll try something like 10. This is 4 minus 100 divided by 10 squared, which is 100. So 4 minus 1, basically, which is positive, increasing. So 5 is a min that I wanted it to be. But I have to be careful on this problem because they are asking for the overall dimensions. What are the overall dimensions? The whole thing. I found x. I can use x to find y because y is 50 divided by x or 50 divided by 5 or 10. So I found y. X is 5, y is 10. But I want the overall dimensions, so I'm going to take my x, which is 5, and add 2. So that is 7, and it's inches by, and then I'll take my y, which was 10, and add 4. So it's 7 by 14 inches. Again, let me back up and go through that again. I found my x. I used my x to find y. But I'm looking for the overall dimensions. What I found here were my inner dimensions. So I need to take my x and plug it into the total bottom length, and my y and plug it into the total height of the poster. So that's where I get my 7 by 14. Again, I'm going to give you an opportunity to try the next one, very similar to 10. So I'm going to pause the video, or have you guys pause the video, give yourself about 5 minutes, and then take a peek at it when you're done and see how you do. I hope that went well for you. I worked my way through and I found x to be 9. I proved to myself that that was in fact a min with my table. I plugged it into my connector, 162 divided by 9 to get 18. And then I took both of those pieces and put them into the real dimensions, the total dimensions of the poster. So I took x, which was 9, and added 4. I took y, which was 18, and added 8. And so my final dimensions were 13 inches by 26 inches. These get better with a little practice, so please don't be discouraged when you do your practice tonight for homework. you will hopefully start to feel a little bit more comfortable. We're going to do one more type of problem today. This is it, and then I'm going to give you your homework assignment. And so we have an engineer designing a box-shaped aquarium with a square bottom and an open top. The aquarium must hold 256 cubic feet of water. What dimensions should they use to create an acceptable aquarium with the least amount of glass? So in this one I want, again, a min, the least amount of graph, but I'm back to a three-dimensional figure. I have an aquarium. So again, we're going to do our best to draw this. I start with a parallelogram. I give my parallelogram some height, keeping in mind we're doing a little bit of perspective here. I will finish off the base on that, and it's an open top so I can see into it. So there is my open top aquarium that we're making. It does tell me that the base is a square, so I will put the same variable on the bottom. If it's a square, I know that the dimensions are the same on the bottom, so x by x, but it doesn't say it's a cube, so the height is different. So I have x by y. And I am trying to use the least amount of glass. Now, keep in mind what we're talking about there. The glass of the aquarium goes on the outside, so I'm looking for surface area, or the combined area of all of the sides of this shape. So I'm going to set up my function, least amount of glass. The front panel, the side panel, the back panel, the other side panel, and the bottom panel are what I'm going to put together to create the aquarium. So I'm going to call this surface area. Let's call that S. Well, the base is x squared. That's an x by x. So that's the area of the base of this. The left side is x by y, x by y. The front is x by y. The right is x by y. The back is x by y. That means the four sides are all x by y. I've got my surface area, but I come across a little bit of a problem. And again, there is that pesky extra variable in here that I don't want. So I need to go back into my original story and see if there is some connector that I can make. And the thing that stands out to me is the fact that this needs to hold 256 cubic feet of water. That means the volume, what it holds inside, has to be 256 feet. So I will do the length times the width times the height, and I want that to be 256 feet. I'm going to solve for the easiest variable to solve for, and it turns out the easiest variable to solve for is the one that I only have to replace once. So I'll do y equals 256 over x squared, and then that will go in for my y. Now I've got to go ahead and continue my math here. My surface area is x squared plus 4x times 256 over x squared. And when I multiply that through, what's going to happen is the 4 will be multiplied by the 256. And remember, this is 4x over 1, so one of the x's on the bottom will cancel out because of the x on the top. So my new surface area formula is x squared plus whatever 4 times 256 is, and that is 1024 over x, because again, one of the x's canceled out, leaving me with just one x on the bottom. So I have another situation where I have an x in the denominator, just like the previous problem, and I want to take a derivative, and it's going to be much, oops, that's a plus, not an equals, much easier for me to do if I just have a negative power as opposed to a fraction. So when I take my derivative s prime, I get 2x minus 1024 x to the negative second. I'm going to set that equal to 0 and also put that negative power on the bottom and make it positive to make my solving easier. I have an extra x in here, and so solving is going to be a little bit trickier, doable, so don't worry. I'm going to bring that 1024 over x squared to the other side, 1024 over x squared, just added it to the other side, left the 2x. I'll multiply the x squared out, leaving me with 1024 equaling 2x cubed. When I divide by 2, I get 512 equals x cubed, and now I need to do the cube root of 512 to get my x. If you have a calculator that allows you to put a root in that's pretty nice and you're comfortable with, go ahead and do that. Otherwise, if you can't find that, just raise it to the 1/3 power. Do put parentheses around it if you're not using the fraction key, but raising it to the 1/3 power will also get you x. When I plugged that in my calculator, I got 8. And I'm going to again go ahead and do a test point in my derivative. I'm going to go ahead and do it in this piece right here, the one that I'm sort of circling around. I will plug in 1. That gives me 2 minus 1024, definitely negative. And then I'll plug in something like 10. That's going to be 20 minus, when I plug it in here, I'm going to get 1024 divided by 100, which would be 10.24. So I have 20 minus 10.24, which is a positive region. If you need to use your calculator again, go for it, not a problem. So I get 8. Now it is in fact a minimum, the least amount of glass that I want to use, so this is a minimum. So what I'm going to do is I'm going to plug it back into my connector to find what y is. So if x is 8, then y is 256 divided by 8 squared. When I plug that all in, I end up getting 4. And so be careful, because this is a 3-dimensional shape. I am going to finalize my answer. This is feet. It is 8 feet, that's what x is, by 8 feet, because it's a square, by 4 feet for my final dimensions. Choose your dimensions by what figure you're looking at. This is a 3-dimensional figure, therefore I need 3 dimensions. Yesterday when we were dealing with the farmer and the rancher, we were looking at 2-dimensional figures, so we only needed 2 dimensions. So watch out what you're looking for. I'm going to call it quits for today. I'm just going to give you your assignment and then have you work and practice on it, and I will see you all on Monday, and we'll be able to answer any questions that you have. And as for homework today, you can do problems 4, 5, 6, 11, 12, and 19. So that leaves you with 6 problems, I think. I just want to double check and make sure. 4, 5, 6, 11, 12, and 19. And then we will go through any questions that you have on Monday. Please just keep in mind that I'm not going to go too far off of the norm when I'm giving you your problems. So there'll only be a few problems that we are going to be looking at, even though there are infinitely many. So just kind of look at what the problem is most like, and then go back, find that in your notes, and see if you can follow the setup until you get comfortable. Other than that, I guess have a great weekend, and I hope all goes well.